Okay, so our problem for today is to sum. Given an array of integers nums and an integer target, return the indices of the two numbers such that they add up to target. Okay, so we know that the input will have exactly one solution, and we know that we can't use the same element twice. We can also return the answer in any order. Okay, so in order to start off with an example, we have the array nums over here, and then we have a target 9. We want to return 0 and 1 as our values because the values at indexes 0 and 1 add up to 9. So in this case, we have 2 and 7 adding up to 9. So in order to find these indexes, the first solution would be to loop through every single element in the array. So we have 2, 7, 11, 15. So for every single value in the array, we want to loop through the array again and then add the elements from that second loop with the element in the first loop to see whether or not those two added together equal the target. So this is a valid solution. However, the runtime of this would be O of n squared because you're looping through every single element, for every single element in the array. So a faster way to do this would be to use a hash map instead and figure out what the complement of each element in the array is. So to kind of elaborate further into what I mean with this, we have the number 2. We know the target value is 9, so we know the complement of this must be 7 because 2 plus 7 equals 9, or 9 minus 2 equals 7. So because we can figure out what the complement is by knowing the target and the current value, which is 9, and just subtracting with the current value, which is 2, we can effectively figure out what number we need in order to get the value, in order to get the final solution. So okay, how do we get this to work? Okay, so an idea would be to have a hash map that loops through every single element you loop through, and you add that current element to the hash map. So you add the value and then you add the index, the value as the key and the index is the value. And then for every single subsequent elements in the loop, you want to check to see whether or not the complement already exists in the hash map. So for example, we have 2. Since the hash map is empty, it won't do anything. So okay, so to start this off with an example, we have 2. Since there's nothing in the hash map, we're gonna just leave we're just gonna add that element to the hash map, because its complement doesn't exist, which is 7. So we add that, and we add the indexes currently at there. The next thing we can do is loop through for the next element. We have 7. What's the 7's complement? It's 2 because 9 minus 7 is 2. Since 2 already exists in the hash map, we can then return its value, which is 0, and then the index of the current element we're on, which is 1, and then we'll have that be the final value. So I can provide a little coding solution for this now. What we're going to do is for every single element, or for I len nums, we're going to want to figure out what the complement is. So comp equals nums. Okay, so nums I, and we want to figure out what the complement is by subtracting the target from the nums. Okay, so now that we have this, we want to check to see if the complement already exists in the hash map, and if it doesn't, you just want to add the current element into the hash map with its index as the value. So if complement, if the complement is in the hash map, we want to return the current index and then the hash map of the complement to get that one's index. Otherwise, we're going to want to add to the hash map. We're going to want to add the current value nums I as the key, and then we're going to want to add the index as the value. Okay, so just to walk this through again, with another example, we have number 3, 2, 4. We know that the complement of 3 would be, in this situation, would be 3 because the target is 6 minus 3 is 3. Like since that doesn't already exist in the hash map, we're gonna want to add 3 in, like the 3 with the index is currently at as the value. We move on to the next one. We have 2. With 2, we want to see whether or not the complement, which is 4, exists in the hash map. It doesn't, so then we add 2 with the index of it, 1, as the value. And finally, for the last value, we have 4. Does the complement exist? 6 minus 4 is 2. Does the complement exist in that hash map? Yes, it does over here. So what we can then do is return the index of the current value, which is 2, and then return the value, or the index of the complement, which would be 1 in this case. So let's confirm this works by running it over here. Okay, great. It works. Yeah, so the time complexity of this one would be O of n, because you're only having to loop through every single element in the array once. The space complexity of this would be O of n, because in the worst case, you'll have to add every single element like in the nums array into the hash map. So yeah, if there's any questions, just leave it down in the comments below, and thank you for watching.